analytic function definition. A single valued complex function f of z is said to be analytic at a point z0 in the domain D of the z plane if f of z is differentiable at z0 and at every point in some neighborhood of z0. Means કે f of z analytic at z0 in the domain D ક્યારે કહેવાય? તો કે f of z is differentiable at z0 અને એના આખા એવરી નેબરહુડમાં z0ના નેબરહુડમાં પણ એ ડિફરન્શિયેબલ થવો જોઈએ. ત્યારે એફ ઓફ ઝેડને શું કહી શકાય? એનાલિટિક એટ પોઈન્ટ z0 ઇન ડોમેન D. In other words, a function f of z is said to be analytic in a region of the z plane if f of z is defined and differentiable at all points in the domain. અહીંયા આપણે ડોમેન લીધો છે ઓપન એન્ડ કનેક્ટેડ ડોમેન. A function analytic in a domain D is also said to be regular or holomorphic in the domain D. If a function is single valued and process a derivative at every point of a domain D except for a finite number of points, we say that the function is analytic in the domain D except for those points. The domain D except for those points are called singular points or singularities. Means કે ડોમેનમાં બધા પૂરેપૂરા ડોમેનમાં તો એના ડેરિવેટિવ એનો મળતો હોય અને ફંક્શન આપેલો હોય સિંગલ વેલ્યુડ હોય અને આખા ઓલામાં ડેરિવેટિવ મળતા હોય પણ ફાઇનાઇટ નંબર ઓફ પોઈન્ટ્સ પાસે ના ડેરિવેટિવ ના મળતા હોય તો એ ડોમેનમાં the function is analytic in the domain. એટલે એ ડોમેનમાં એનાલિટિક કહેવાય પણ જે ફાઇનાઇટ નંબર ઓફ પોઈન્ટ્સ જે છે ત્યાં એનાલિટિક ના થાય તો એ પોઈન્ટ્સને શું કહેવાય? તો કે એ પોઈન્ટ્સને કહેવાય સિંગ્યુલર પોઈન્ટ્સ or singularities. Now Cauchy-Riemann equation the famous equation CR equation statement: the necessary and sufficient condition for the necessary and sufficient condition for the function f of z is equal to u x comma y plus iota v function of x and y. Here f of z is equal to u function of x and y plus iota v function of x and y. To be analytic at the point z is equal to x plus iota y in a domain D is that the partial derivative del u by del x, del u by del y, del v by del x and del v by del y must exist and satisfy the Cauchy-Riemann equation. Here the partial derivative of x and y, partial derivative of x and y must exist and satisfy the Cauchy-Riemann equation. Partial derivative del u by del x is equal to del v by del y, means ux is equal to vy and uy is equal to minus vx at the point x and y of domain D. First, the condition is necessary condition. તો એનો પ્રૂફ જોઈએ આપણે. Let f of z is equal to u function of x and y plus iota v function of x and y be an analytic function at the point z in a domain D, and the derivative of function f dash of z is equal to limit del z tends to 0 f of z plus delta z minus f of z upon delta z. Since function is given, analytic function is given, since the function is analytic f dash of z exists and has a unique value independent of the mode of approach of delta z to 0. Thus, we may select two paths, path 1 and path 2 in the figure. In this figure, this is path 1 and this is path 2. Path 1, path 2. and equate the result z is equal to x plus iota y, delta z is equal to delta z is equal to x plus iota y. So z plus delta z is equal to x plus delta x plus iota y plus delta y. Hence delta z is equal to delta x plus iota delta y. So now f dash of z is equal to limit delta z tends to 0. Put the value of z, put the value of z, put the value of z, z and delta z in this equation, equation number 1. This is equation number 1, and put the value z and delta z. So we get f of z plus delta z is equal to u of x plus delta x, y plus delta y plus iota v of x plus delta x, y plus delta y minus u of x comma y plus iota v of x comma y upon delta x plus iota delta y. The value of f of z plus delta z, z plus delta z ની વેલ્યુ મૂકી અને f of z ની વેલ્યુ z ની વેલ્યુ x પ્લસ આયોટા વાય મૂકી એટલે આપણે મળ્યું આ ફોર્મ. આને ઇક્વેશન નંબર 2 આવી દો. We find first now choosing path 1 as figure, thus we let delta y tends to 0 first, and then delta x tends to 0 after delta y is 0. Delta z is equal to delta x. delta z માં delta y 0 થાય તો delta z is equal to delta x. then equation 2 takes the form, then equation 2 becomes equation 2 માં ડેલ્ટા વાયની વેલ્યુ 0 મૂકીએ તો આપણે મળે f dash of z is equal to limit delta x tends to 0 u of x plus delta x comma y minus u of x comma y upon delta x plus iota v of x plus delta x comma y minus v of x comma y upon delta x is equal to બંનેને લિમિટ આપી દઈએ તો લિમિટ ડેલ્ટા એક્સ ટેન્સ ટુ 0 u of x plus delta x comma y minus u of x comma y upon delta x plus iota limit delta x tends to 0 v of x plus delta x comma y minus v of x comma y upon delta x. This is partial derivative of u with respect to x, and this is partial derivative of v with respect to x. So this is f dash of z is equal to del u by del x plus iota del v by del x. Similarly, we can find using path 2 from the figure delta this is delta z tends to 0, delta x tends to 0, and then this is delta y tends to 0. So now similarly we can select the path 2. Similarly if we choose path 2 in the figure, we let delta x tends to 0, this direction, we let delta x tends to 0 first, and then delta y tends to 0, and then delta y tends to 0. After delta x is 0, delta z is equal to iota delta y. So from equation 2 we now obtain we now obtain from the equation number 2, delta iota delta y tends to 0. So f dash of z is equal to limit delta y tends to 0 and u of x plus delta x x comma y plus delta y minus u of x comma y upon delta x is equal to 0 પુટ કરશું આપણે એટલે iota delta y plus iota limit delta y tends to 0 v of x comma y plus delta y minus v x comma y upon iota delta y. So this is equal to partial derivative of u with respect to y. So del u by del y upon 1 upon I plus this is partial derivative of v with respect to y. So f dash of z is equal to this. Equation number 4 આપી દઈએ અને આ equation number 3. Since f dash of z is unique, the above two values of f dash of z must be equal. So from equation number 3 and 4, del u by del x plus iota del v by del x is equal to minus iota del u by del y plus del v by del y. So now equating the real and imaginary part in equation 3 and 4 we obtained. This is the equating real and imaginary part. Equating the real and imaginary part in 3 and 4 we obtain Cauchy-Riemann equation 1. So del u by del x is equal to del v by del y. and del u by del y is equal to minus del v by del x. Now if f of z is equal to u plus iota v is analytic at z, it is necessary that the for partial derivatives del u by del x, del u by del y, del v by del x, del v by del y should exist. And satisfies the Cauchy-Riemann equation, satisfy the Cauchy-Riemann equations. Now we see the B part of the theorem. The condition is sufficient. Condition is sufficient condition. We shall show that the conditions are also sufficient for the function f of z to be analytic at point z, provided partial derivative of u and v of x and y exist and continuous in the domain D. So we see the proof. We shall show that these conditions are also sufficient for a function f of z to be analytic at a point z, provided del u by del x, del u by del y, del v by del x, del v by del y exist and are continuous in domain D. તો સફિશિયન્ટ કન્ડિશન શું છે? તો કે પાર્શિયલ ડેરિવેટિવ એક્ઝિસ્ટ થવા જોઈએ અને કન્ટિન્યુઅસ હોવા જોઈએ ઇન ધી ડોમેન. We have f of z plus delta z is equal to u of x plus delta x comma y plus delta y plus iota v of x plus delta x comma y plus delta y is equal to u of x comma y plus del u by del x into delta x plus del u by del y into delta y plus iota v of x comma y plus del v by del x into delta x plus del v by del y into delta y plus up to infinite by Taylor's theorem for function of two variable is equal to u of xy is equal to f of z plus del u by del x plus iota del v by del x into delta x plus del u by del y plus iota del v by del y into delta y omitting terms beyond the first power of delta x and delta y, or f of z plus delta z minus f of z ને આ બાજુ લઈએ તો -3 is equal to remaining terms del u by del x plus iota del v by del x into delta x plus del u by del y plus iota del v by del y into delta y. Now using CR equations, del u by del y is equal to पुट करिए આપણે माइनस del v by del x, del u by del x प्लस आयोटा डेल वी बाय डेल एक्स इंटू डेल्टा एक्स प्लस माइनस डेल वी बाय डेल एक्स बिकॉज यू वाई इज इक्वल टू माइनस वी एक्स प्लस आयोटा डेल वी बाय डेल वाई अहीं आपण यूज करिए આપણે કે यू वाई इज इक्वल टू वी एक्स सो शेयर कंडीशन यूज करिए अहीं तो मळे आपने डेल यू बाय डेल एक्स इंटू डेल वाई using CR equation. So f of z plus delta z minus f of z is equal to del u by del x plus iota del v by del x into delta x plus iota del v by del x plus del u by del x both x टर्म x ना टर्म में लावी नाख्या बधाने x ना टर्म में लावी नाख्या बधाने अने डेल्टा y सो नाउ कॉमन आउट del u by del x plus iota del v by del x into delta x plus iota delta y this is delta z so del u by del x plus iota del v by del x into del z so f of z plus delta z minus f of z upon delta z is equal to del u by del x plus iota del v by del x so now derivative of f of z is equal to limit delta z tends to 0 f of z plus delta z minus f of z upon delta z હવે આની વેલ્યુ આપણે જાણીએ છીએ this value del u by del x plus iota del v by del x is equal to del u by del x plus iota del v by del x or del v by del y minus iota del u by del y which by equation 3 or 4 proves the sufficient condition for f of z to be analytic, not first. અહીંયા આપણે સફિશન્ટ અને નેસેસરી કન્ડિશન કમ્પ્લીટ થયા હશે, બરાબર. નોટ ઇફ f of z is analytic, જ્યારે f of z એનાલિટિક હોય ત્યારે then derivative of f dash of z is equal to એક તો del u by del x plus iota del u by del x plus iota del v by del x. અને હવે સીઆર કન્ડિશનનો યુઝ કરી અને આપણે અલગ અલગ ફોર્મમાં આપણે લખી શકીએ. તો એને તો લખીએ આપણે ડેલ યુ બાય ડેલ એક્સ એમનો રહી દઈએ અને ડેલ વીએક્સને આપણે વીએક્સ ઇઝ ઇક્વલ ટુ માઇનસ યુ વાય વેલ્યુ મૂકીએ આપણે તો માઇનસ આયોટા ડેલ યુ બાય ડેલ વાય. હવે ડેલ યુ બાય ડેલ એક્સ છે એની વેલ્યુ મૂકીએ આપણે ડેલ વી બાય ડેલ વાય. સો ડેલ વી બાય ડેલ વાય માઇનસ આયોટા ડેલ યુ બાય ડેલ વાય હવે ઇઝ ઇક્વલ ટુ હવે ડેલ યુ બાય ડેલ વાયની વેલ્યુ મૂકીએ આપણે માઇનસ ડેલ વી બાય ડેલ એક્સ. સો આપણે વેલ્યુ મળશે ડેલ યુ બાય ડેલ વાય પ્લસ આયોટા માઇનસ માઇનસ પ્લસ થઈ જશે અને ડેલ વી બાય ડેલ એક્સ. using CR equation ux is equal to vy and uy is equal to minus vx. Second, the Cauchy-Riemann equation are referred to brief as a CR condition. means કે આપણે યુઝ કરી શકીએ CR કન્ડિશનનો યુઝ કરી શકીએ CR ઇક્વેશનનો વાપરીએ. The CR equation are not sufficient for analytic function એનાલિટિસિટી માટે ઓનલી CR કન્ડિશન CR ઇક્વેશન સફિશિયન્ટ નથી, બટ ધ પાર્શિયલ ડેરિવેટિવ્સ ઓફ યુ એન્ડ વાય શુડ બી કન્ટિન્યુઅસ હોવા જોઈએ. ધ પાર્શિયલ ડેરિવેટિવ ડેલ યુ બાય ડેલ એક્સ ડેલ યુ બાય ડેલ વાય ડેલ વી બાય ડેલ એક્સ એન્ડ del v by del y should be continuous. Also continuous. Other note, all polynomial function are continuous and all polynomial function exponential function means e raised to x વાળા ફંક્શન બધાય. અને થર્ડ ટ્રાઇગ્નોમેટ્રિક ફંક્શન મીન્સ સાઇન ફંક્શન કોસાઇન ફંક્શન વગેરે કન્ટિન્યુઅસ છે. ઓલ કોઈ પણ રીઝનમાં આ ફંક્શન કન્ટિન્યુઅસ જોવા મળશે તમને. Now we see the example for analyticity. example, discuss the analyticity of the function. Discuss the analyticity of the function mod z square and z into z bar at any point z. Solution. Here f of z is equal to આપણે લખી શકાય u ફંક્શન ઓફ x and y પ્લસ આયોટા v ફંક્શન ઓફ x and y is equal to mod z square. mod z square ને લખી શકાય z into z conjugate is equal to z into z conjugate is equal to x plus iota y and into x minus iota y is equal to x square plus y square. So u is equal to x square plus y square plus iota into 0 and v is equal to 0. So now partial derivative of u and v, del u by del x is equal to 2x, del u by del y is equal to 2y, del v by del x is equal to 0 and del v by del y is equal to 0. So the CR equation del u by del x, ux is equal to vy, so del v by del y and del u by del y is equal to minus del v by del x. Put the value of the partial derivative. So del u by del x is equal to 2x is equal to 0 and 2y is equal to 0, so both are not equal. So CR equation are not satisfied when x is not equal to 0 and y is not equal to 0, that is unless z is equal to 0. Thus f of z is not analytic at the point z not equal to 0. Check whether function is analytic or not. First, f of z is equal to e raised to z square. Second, f of z is equal to e raised to z conjugate. And third, f of z is equal to sin z. So first solution, here a function f of z is equal to e raised to z whole square. So f of z is equal to e raised to x plus iota y whole square is equal to e raised to x square minus y square plus iota 2xy. So we can write e raised to x square minus y square into e raised to 2 iota x y. But e raised to I theta is equal to cos theta plus iota sin theta. So this is equal to e raised to x square minus y square into cos 2xy plus iota sin 2xy, because e raised to I theta is equal to cos theta plus iota sin theta. So is equal to e raised to x square minus y square into cos 2xy plus iota e raised to x square minus y square into sin 2xy. So we get this is u and this is v. This is real part of the complex number and this is imaginary part of the complex number. So u is equal to e raised to x square minus y square into cos 2xy, and v is equal to e raised to x square minus y square into sin 2xy. Now we find the partial derivative of u and v. Now ux is equal to e raised to x square minus y square into minus sin 2xy into 2y plus cos 2xy into e raised to x square minus y square into 2x. And is equal to 2 common નીકળશે બધામાંથી, e raised to x square minus y square common અને cos 2xy minus sin 2xy into multiply y અને આની મલ્ટીપ્લાયમાં આવશે x. Now ux is હવે uy મેળવીએ. uy is equal to e raised to x square minus y square into minus sin 2xy into 2x plus cos 2xy into x square minus y square into minus 2y આને સિમ્પ્લિફાઈ કરીએ તો e રેઝ ટુ x સ્ક્વેર માઇનસ વાય સ્ક્વેર કોમન, 2 કોમન y into cos 2xy minus x into sin 2xy. Now vx is equal to e raised to x square minus y square into sin of cos 2xy into 2y plus sin 2xy into e raised to x square minus y square into minus 2y, sorry minus 2y, हाँ नहीं into 2x, sorry into 2x, so is equal to e raised to x square minus y square common, બધામાંથી 2 કોમન નીકળશે અને y into cos 2xy plus sin 2xy into x. This is vx and vy is equal to e raised to x square minus y square into cos 2xy into 2x plus sin 2xy into minus 2y into e raised to x square minus y square is equal to બધામાંથી 2 કોમન નીકળશે into e raised to x square minus y square common, cos 2xy into x minus sin 2xy into y. આને આપણે ઇક્વેશન નંબર 1 આપી દઈએ, આને ઇક્વેશન નંબર 2, ઇક્વેશન નંબર 3 and ઇક્વેશન નંબર 4. So here ux and vy, ux is equal to minus vy, minus common લઈએ તો sorry ux is equal to vy complete from equation 1 and 4. ux is equal to vy and from equation number 2 and 3, equation number 2 and 3 અહીંયા equation number minus આવશે. So equation from equation number 2 and 3 uy is equal to minus vx. So f satisfies CR condition and the partial derivative ux, uy, vx and vy. ux માં આપેલું છે e raised exponential function છે અને trigonometric function છે. Every trigonometric function and exponential function are always continuous. So this is ux is continuous, this is exponential function and this is trigonometric function. So this is continuous and vx and vy also continuous. So ux, uy, vx, vy are continuous function. So f is analytic. Remaining two homework. Thank you.